Okay, let's look at the constants that we have multiplying our transfer functions. So in general, anytime we have these transfer functions, h of s, it's always equal to k times something else. All right. So that something else could be for instance, we could have something like 10 times s plus 1 over s times s plus let me write it this way, times 0.1 s plus 1. Okay. So in this case, I'm saying my g of s is equal to s plus 1 over s times 0.1 s plus 1. In other words, my g of s is the part that has the poles and zeros. Okay, so if I just said, okay, let's let s equal j omega, okay, and I said let's take 20 log 10 of the magnitude of h of j omega, that would be 20 log 10 of the magnitude of k times g of j omega. Okay, if I did it like that. And g of s could be anything. Just in my example, I'm saying it's this. Okay, so because of the fact that I am taking the magnitude of a product, I can write this as 20 log 10 of k times, parentheses here, the magnitude of g of j omega, like that. All right, now if I have the log of a product, that becomes the sum of the logs. So I have 20 log 10 of k plus 20 log 10 of g of j omega, like that. Okay, so what that sort of says for me is that the multiplier k, okay, the multiplier k basically just shifts the graph of everything else up or down. In other words, I'm just adding a constant value to the graph of everything else. Now, the thing we got to be mindful of is we could have two types of values for k, right? We could have k positive, and we could have k negative. Now notice, if k is negative, we're taking the absolute value of it anyway. So whether k is positive or k is negative, right, this value here still becomes 20 log 10 of k, right? Still a positive number. This guy still becomes 20 log 10 of the absolute value of k, because I'm always doing the absolute value of k. That's what I shifted up by. So what happens if k is negative? Let's say, for instance, that k was equal to negative 10. Well, that just means that it's equal to 10 with an angle of 180 degrees, right? So the magnitude of any number is always positive, right? If I have a negative number, it just means that I have minus 180 degrees. So what does that mean exactly? Well, in terms of the magnitude, if I had k equal to minus 10, then I would shift my graph up or down by 20 log 10 of 10, which if you evaluate that becomes 20 dB. So I would take whatever my graph is and I would shift every point on the graph up by 20 dB. Now, if I had that though, just to be real careful about it, right, that would matter if I'm talking about the angle, right? So if I said the angle of h of j omega, that would be equal to the angle of k times g of j omega. So if I have two complex numbers multiplying each other, I can say it's the angle of k plus the angle of g of j omega, like that. Well, the angle of k in this case is 180 degrees. So if I get a negative sign, it doesn't have any effect on the magnitude, right? Because I'm always taking the magnitude of any number, which always gets rid of the negative sign. Okay. If I do have that negative sign, it matters for the angle equation. All right. So that's kind of an important result that you'll want to make use of.